Welcome back to our statistics learning session. Today, we'll be talking about properties of chi-square distribution. Last time, we talked about the definition of chi-square distribution. Now, we'll be elaborating regarding properties of chi-square distribution, specifically expectation and variance, first moment and second moment of a chi-square distribution. Let there be a V variable which is a chi-square distribution with a k degree of freedom. If this is true, then 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 v is equal to then v equal to what? V is equal to j1 square plus j2 square up to jk square. If v has a chi-square distribution with k degree of freedom, then this should equal to that. Now, expectation of v is equal to expression of v equal to expression of z1 square plus expression of z2 square up to expression of gk square. Now, next step is to find what is the expression of z1 square. To do this, we can use a formula. The formula we can use uses variance of z1 is equal to expectation of z1 square expectation of z1 square. Here we know what is the variance of z1. The variance of is a z1 is a standard distribution. It is a Gaussian with the variance of 1. Therefore, variance of z1 is 1. Expectation of z1 square, this is what we need to find out, and we will need to know what is the expectation of z1. It is a 0 because it's a Gaussian distribution. That's why it's going to be 0 here. Therefore, EZ square equal to 1. Now we can replace EZ1 square by 1, 1, 1. Therefore, up to this will be up to k terms. K. What is the variance V? Variance V. How do you know what's the difference of variance V? How can you find that out? Variance V is a variance of each of these terms that makes up the V. That is variance of Z1 square plus variance of Z2 square up to variance of zk square. Now we have these k terms that make up the variance of v. Next step is to understand what is the variance of z1 square. To do that, we need to reuse the formula for variance of a variable. That is, variance of z1 square is equal to expectation of z1 4, which is a fourth moment of variable z1, and expectation of g square expectation of g square. Now we know z1 square expectation of z1 is 1. Now we know expectation of z1 is 1 from the expression we already calculated earlier. What is the expectation of z4? Z4 is a fourth moment, is kurtosis, and since Z1 is a Gaussian, the fourth moment of Gaussian is 3. It is a well-known parameter 3. Therefore, variance of G square is 2. Now there are k terms. There are k Z1 square. Therefore, variance of V is equal to 2k. When we learn this, there are a few things we want to keep things in context, such as kurtosis of random variable. It shows, it measures how heavy the tails are of a Gaussian. There's a peak, and peak has its tails, and fourth moment, which is a kurtosis, kind of measures how fat or how heavy those tails are. And looking at this, chi-square distribution, chi-square distribution, if the k, which is a degree of freedom, if degree of freedom is large enough, then chi-square distribution is approximately a Gaussian distribution with a mean k and variance 2k because of central limit theorem. Also, what we need to understand here is that the chi-square distribution has a peak, and the size of the width of the peak is a variance, is a square root of variance, that is the square root of k, and k, and what is k? Is a square root of 2k. Is a square root of 2k. What I'm saying is that the standard deviation is the square root of 2k. Now k is a mean. As mean is smaller, the standard deviation also becomes smaller. As a mean becomes larger, the standard deviation also becomes larger. That is, the peak will become fatter. The peak will become fatter. But the mean is smaller, the peak will become concentrated. The peak will become sharp and mean and tall. Therefore, the shape of the peak depends on the mean of chi-square distribution. That's all for today. Let me quickly summarize what we learned today. We learned about properties of chi-square distribution, especially mean and variance of a chi-square distribution. Using formula of variance, we determine that the expectation of a chi-square distribution is k, and variance of chi-square distribution is 2k. Hence, the standard deviation of chi-square distribution is square root of 2k. That's all for today. I'll see you next learning session. Thank you so much.